All right, this is a 1992 Geo Metro, which I converted to be all electric. I'm going to step through the process of what I did and how it got to be where it is. So one of the first things I did was pull out the engine. This thing was originally equipped with a 1 liter, 3-cylinder, 5-speed manual transmission. I pulled out the motor some time ago, and I replaced it with I replaced the motor with this large DC motor, which was the drive motor off of a forklift. I got that salvaged off of eBay, and then I have an Alltrax programmable 72 volt 300 amp controller, which was originally intended for a golf cart, which I used to control the motor. Back here you can see that there's a solenoid, which is used for the safety feature to turn on and off the main power to the motor. This is the throttle box. So the controller uses a 0 to 5,000 ohm potentiometer. So I rigged up the throttle cable to a wheel, which is connected to the potentiometer, and that feeds into the programmable controller and tells you which way to go. It's programmable because you can tell how you want the throttle response based on the resistance of that throttle pot. This chamber here allows me to maintain the power brakes. So this had boost assist, vacuum boosted braking, which typically would run off the manifold, the intake manifold, but because there's no longer an intake manifold, I had to make up this vacuum chamber. Inside of here is a small DC pump. They're medical pumps, and they're used in breast pumps and insulin pumps and things like that. You can find them pretty cheap on eBay. They run off of a DC 12 volt battery, which is the main battery here. It pumps down this chamber, which is indicated by this vacuum. So I had just recently turned it on, so it still has a little bit of vacuum pulled on it. You can see because the hoses collapsed as well. But this goes up to a sensor that turns that vacuum pump on and off based on the vacuum level. As you actuate the brake, the vacuum drops, and then the pump will kick back on to restore it. The main electrical system is still intact. So this is the original 12 volt battery, which drives all the main electrical components, including the brakes, brake vacuum. It runs the lights, the radios, everything else. The main electrical system is still intact and runs off that 12 volt system. The propulsion system is a 72 volt system, and those batteries are in the back, and that is independent of everything else. So if you drive this at night or anything else, if you run the radio, those type of things, you're not draining the propulsion batteries. Instead, you should get a consistent propulsion range day or night, no matter what other auxiliaries that you're pulling, because your auxiliaries are running off this 12 volt independent system. So that's all of it. One of the key features is pulley that I have. So I have a 1.7 to 1 gear ratio or pulley ratio. That lower pulley goes into the input housing in my transmission. So this is a bearing. There's the smaller pulley, the pinion. Inside here is the thrust bearing, and on the other side of this is the flywheel with the clutch plate and everything else. So the clutch is completely fully functional. When you push on the clutch, you're pushing on this shaft and the flywheel, and that's why you have a thrust bearing along with the tapered radial bearing, so that it can take the thrust and the radial loads. The motor here, that 1.7 to 1 gear ratio, allows the motor to spin at roughly the same RPMs while the transmission is in first gear that the motor would spin if the transmission were in second gear and directly coupled. Therefore, I'm able to take advantage of the high low-end torque provided by a DC motor and hopefully get higher top-end speed, which I found to be true because I've been able to get this thing up to about 50 miles an hour, and I don't think that that's its top-end speed with the 72 volts. So I can run through all the gears because the clutch is completely functional, and that's been a big help. So there's a last look at it. If we go around to the batteries, I keep the batteries in the back. So in the back is the battery pack. Right now I just have 4 used car batteries, which I got from a junkyard. 3 of these batteries are not any good anymore, and they barely hold a charge. But that's okay, because I only got these not for a permanent use, but just for a testing and to get me up to speed. These 2 are fairly recent RV batteries, which ideally what you want to do is have at least 100 amp hours. I think both of these have 110 amp hours in them, and they're fairly new. What you'd want is actually 6 of these 110 amp hour batteries, and I think with 110 amp hours you should be able to get about 20 miles of range out of this. I have a off-the-shelf 12-volt battery charger here, so when I want to charge the batteries, I charge them one at a time for now. Ultimately in the future, of course, you'd want to get a 72-volt charger, and that way you can just plug in the car and just charge all batteries at the same time. But as it is, I have to charge each battery by itself using a 12-volt off-the-shelf charger, which isn't a bad way to go. If you got 6 of those off-the-shelf chargers, you could just charge all 6 of them at the same time independently. That's one option. Okay, going inside, you can see it's pretty clean inside. You have the display panel here. Of course, when you turn it on, I put on a couple of indicator lights. So when you turn the key, you are ready to go. Everything is ready to, everything still works. So the radio still works. Shut that off. The power, this still works. The fan, of course, again, all that runs off that 12-volt auxiliary motor. So you're not killing your propulsion or your range as you run your radio and all your other things. Because there's no engine, there's no heater, of course, and this car was never equipped with AC, so none of that existed in the original gas-powered motor, and it doesn't exist now. So that's it. You just turn the key, it says it's ready to drive, and away you go. So it's a 5-speed manual transmission. When you hit the gas, the solenoid kicks on, showing that you get power. You can hear the click. One of the things that I've added here, because the temperature doesn't mean anything now, so I've added this this amp meter, so that you can draw. So as you drive, you can tell how many amps you're drawing. The speedometer seems to work just fine. Over here I've added a couple of switches. One is to kill the vacuum switch, so your brake vacuum, you can turn that on and off if you will, and then a couple other switches too. So that's it. Very clean inside, and it's been a decent car ever since. So that's it. It's been a pretty good car. In a moment here we're gonna go ahead and actually run the motor, and you can see it get going, and then we'll take it for a drive. And we're gonna run it here. You can see it goes. Of course, the car is in neutral right now, so nothing's going to happen. But you can see the gears spinning around. And in a moment, we'll take it for a drive.
Should I?